Welcome to this video on Venn diagrams. In this particular video, we're going to have a look at how we can use a Venn diagram to solve a numerical problem. So consider a tennis club has 42 members, 13 have fair hair, 15 have blue eyes, and 22 have neither fair hair nor blue eyes. And part A of the question asks us, use a Venn diagram to show the information presented above. So to do that, I'm going to quickly sketch a basic Venn diagram. So I'll start off with a rectangular box as such, and then I'll draw two circles, and I'll make it such that both of the circles overlap. Now the reason I'm going to make them overlap is because I'm just going to assume that there will be overlap, and if there's not, then this overlapping section will equal 0. Now to finish annotating the diagram for the basics, we'll say that it is of type, or the universal set is on the outside, and the universal set U is going to refer to the tennis club and its members. And then I'm going to say that there are two more sets here. So we've got 13 have fair hair and 15 have blue eyes, and 22 have neither fair hair nor blue eyes. So there's two additional sets here as denoted by the two circles. So we'll say that people with fair hair are of set F and people with blue eyes are of set B. Now to continue with the annotation, I'm going to write A, B, C, and D. So these variables in here represent the amount of people within the sets themselves, or the areas of the sets. So A would be the amount of people with fair hair but not with blue eyes. Little b here would be the amount of people with fair hair and blue eyes, and C would be the count of people with blue eyes but no fair hair. And D would represent everyone who has neither fair hair nor blue eyes. So looking above, we can see the various equations, and I'm going to try and figure out the distribution of the people based on the information I've given up here. So what we can see is, we'll say A plus B plus C plus D. They all have to sum to a grand total of 42, because it tells us in the question there are 42 members within the tennis club, or there are 42 items within the universal set. Now we can condense that down further and say there are 22 people who have neither fair hair nor blue eyes. So this little statement here, it tells us that the amount of members in set U that are not a part of set F or B is equal to 22. So I can say that D equals 22. So that will make it such that our equation 1, or the first one, will be A plus B plus C plus 22 equals 42. And then taking 22 from both sides to break the equation down, it will be A plus B plus C. Now there's some more information that we can derive from this equation, and we can say that the number of people with fair hair is A plus B, and it tells us up here the amount of people with fair hair is 13. So this new equation, getting this value and putting it into the equation up here, so this equation here, putting the information up here, we can see that 13 plus C equals 20, and therefore C must equal 7. So what I'm going to do now is I'm going to start dropping the information back into our Venn diagram. So I'll get a nice copy of that so we can keep that old one as a reference. Perfect. Now dropping in D we have 22. Dropping in the value of C we have 7. And then we've still got A and B, so we've got to compute the values of A and B. So what else do we have? We've got 15 people have blue eyes. So an equation we can write for that is B, changing my pen, B plus C equals 15. And we already know the value of C is 7. So it will be B plus 7 equals 15. And then it becomes 15 minus 7. So B is equal to 8. So putting in the value of 8 there. And now we're left with one final value we need to solve for. Now recall, we could either do it two ways. So we could grab this equation up here and solve it, or we could grab this equation or either of these two equations and substitute in B and C. I'm going to take the easy route, and I'll take this one here, and we'll say A plus B equals 13. We know the value of B is 8. So, solving, we can say that A equals 13 minus 8, and 13 minus 8 is equal to 5. Thus, the final section of the Venn diagram is going to be, or have, 5 members. Now, going to part B of the question, find the number of members with fair hair or blue eyes. So, fair hair or blue eyes, that would be the union. So, the union of F and B is equal to, and remember it's in number, so we'll write it that way, is 5 plus 8 plus 7, and that is going to be equal to 20 people. And similarly, part 2 of section B is fair hair but not blue eyes. So we can write this as number of people with fair hair, so the intersection of fair hair but not blue eyes, and that is going to be, we can shade the area, so fair hair would be this part here but not blue eyes, so it's exclusive of the 8 and the 7, so that would be simply 5. So there are 20 members who have fair hair or blue eyes, and there are simply 5 members who have fair hair but not blue eyes. So this was an example of how we can use Venn diagrams to solve numerical problems.